So here we are going to be going through the second of the lesson practices for chapter 1. And just to kind of recap what we went through in chapter or lesson 2 was the fact that we're reintroducing the idea of domain being the input values, all the possible input values, and the range being all the possible output values. And then we are now going to be taking those ideas and being able to understand when are the domain and ranges discrete, like when they have distinct or separate values, versus when they have a continuous domain or range where it includes all the values in an interval. So as we go through here, we're going to be kind of working through those and kind of seeing the different ways that we write the domain and range, depending on if it's discrete or continuous. So without further ado, let's go ahead and get started with problem number 1. We're asked to determine whether the domains and ranges are discrete or continuous. So for number 1, we say, hey, the domain is going from left to right. It's our x values, right? So I have, let's call this -10 over here. That's going to be where I'm starting. And then I go all the way over to the right here at, let's say, around +10. Again, it's in between some numbers here, but that's what I'm going to use. In this, it includes every x value in between, right? Whether it's, the fractional decimal numbers or the whole numbers in between. We have this line that includes every x value between, let's say, -10 and +10. So we would call that domain continuous. Now, the range is a little bit different because when we're talking about range, we're talking about the outputs or the y values. And so our lowest is where I'm going to start here at -5. I see that my function, this blue line, starts at -5. That's its lowest output or y value. And then again, it includes every decimal or fractional number in between, along with the integers, all the way up to when we get to +5. So in this one, I would say that the range for this function is also continuous. Now, the second one, number 2, is a little bit different because we're talking about the domain. If we, let's say, again, use this idea that it's going from around -10 to +10, it looks like it stops here at this specific point at -5, but because it picks up again at -5, we're still going to say that that domain here is continuous because at 0 here, even though it stops, it picks right up here and continues and includes every value from the x value of -10 all the way to the x value of +10. Whereas for the range, now the range we're looking at outputs and y values, and so we see that there are some missing points along this one where when we start here at -2, there are no y values between -2 and when we get to this line right here at the y value of 0. So we have very distinct or discrete range values because we have, -2, then 0, then 2, and then 5. So I would say that this range here is discrete. So for number 3, we're asked to look at this function f of x, this blue graph right here, and it says to write the domain and the range of f of x. And so for the domain, we'll start with the domain. Because we look at this and we see that it's a continuous function, right? We're going from what looks like the x value of 0, and it includes every value. It's not distinct points. It's continually going all the way to, call it, the x value of 10. The way we write that domain is what we have right here. I'm underlining in orange because we are going from the x value of 0 all the way to the x value of 10. And so when I read this, right, the x value here is saying that it's greater than or equal to 0, so something bigger than 0 or equal to it, but less than or equal to 10. So we say when we're writing this domain here, the x values go from 0 to 10. The range, when we're doing the range here, we're looking at y values. And the weird part about the range for this one here, or for any function really, is that the range, we want to go from the lowest y value or output or f of x value to the highest. And so even though when we normally read from left to right, we may think that this function, starts here and then goes down and then ends here. And so we may think the ending y value would be 0, but it's not really the case because we want to go from the smallest y value to the largest. And so the smallest y value actually is ending up 0 here. And so I'm kind of starting my range when I write it at 0, and I'm going up to what looks like the y value of 8. And so when I write the range here, the lowest y value is 0, and the highest y value is 8. And I would say, most of the time, if not all the time, we write it in order from least to greatest when we're writing these domains and ranges, because we want to be consistent. And we kind of want to start from, the smallest y value, which in this case was 0, going up to the biggest y value, which is 8. And that will keep these inequality symbols here the same every single time. And so really all we have to change is what's the first number, or the lowest value, and what's the second number, which is going to be the highest value. So for number 4 through 6, we're going to use the same graph here, and it asks us to determine the domain of g of x for specific instances. So the first one, number 4 here, talks about all of the line segment. So the line segment here looks like this straight part, and I'm really just looking for the domain, so the x values. So the line segment starts right here, and it looks like it ends at the x value of 6. And so when we're looking at this, we can kind of see that we're looking at x values. And so we really want to say, okay, it starts at the x value of 4, that line segment, and ends at the x value of 6. And so our line segment goes from 4 to 6. For number 5, we are asked about the domain of the parabola, which is this part right here. And again, the domain meaning we are going from the first x value to the last x value. Again, in this one here, the first x value is 0, and then it's a parabola all the way until we hit that x value of 4. Now the domain of our discrete points here, so I can kind of see a couple things that are in common here. When I look at the graph, I see 1, 2, and 3 points. Whereas in the answer here, I can see that it's going to be 3 different answers, which makes sense. And so when I'm doing this, I'm going to go ahead and choose these x values here, which would be 7, 8, and 9 would be my discrete points. And they're all the x values because we're talking about the domain. Number 7, we are asked to select all the discrete ranges. And so when I'm doing this, remember discrete means like very distinct points. That doesn't include every value. So when I talk about A here, it says all integers from 3 to 8. So that's not a discrete range. That includes, those are integers. So it actually is a discrete range because we are talking about just the whole numbers. We are not including those decimal or fraction answers here. So I would say that, yes, this is a discrete range, specifically because of this word integers here that I missed at first. The second one, however, says from 0 to 2. And so it includes every value between 0 and 2, which means that it is not discrete. That would be continuous. For C, it says g of t is greater than 3. That includes any value greater than 3, which includes 3.1 and 3.111 and 3.111111 and so on and so forth. And so that involves a continuous range here. So not that one either. For D, it says all numbers from 1 to 3. So since it says numbers and not integers, that is including any decimal or fractions, which means that that is continuous. And then E here says y is equal to 2.4 and 3.4. Those are two very distinct or discrete values. And so we would say that that is a discrete range. So our answers for number 7 are A and E. For number 8, it says sketch a graph that has a discrete domain of the even integers. So I'm going to have to choose very specific numbers, and I'm only using even whole numbers. Whereas when I'm looking at the range, it's got to be continuous from 0 to 8. So there's a couple different ways that this could look. And the way I'm going to draw it here, I'm going to scroll up a little bit, is I'm going to start at 2 here, and I will say that we're going to have this line right here from 0, the y value from 0 to 2, but the x value is just at 2. And then we're going to skip over here to the x value of 4, skip over here to the x value of 6, skip over here to the x value of 8. And so what this does is I can obviously see it's got a discrete domain because I'm missing all of the values, in between 2 and 4, the values in between 4 and 6, and the values between 6 and 8. but the range is continuous because when I look at this, I can see that it's going from 0 to 2 here in the y values, then it picks right up over here and goes from 2 to 4, from 4 to 6, and from 6 to 8. So it's continuous on the range from 0 to 8. Now, this is just one example of the way it could look. There's lots of options, but this makes both of those things true. All right, moving on to our spiral review, the stuff that we should know that is from previous lessons and things that we're going to need going forward. So number 9 asks for us to write the coordinates of this function's minimum. So minimum, I'm looking at y values. Where is the lowest y value? I see that I'm looking for this point right here. That's my lowest y value. It says coordinates, right? So I actually want the point, the x value, and the y value. My x value, it looks like this graph is going up by 2s, 2, 4, 6, 8, 10, 12, and 14. So x value of 14, and then it's going down by 2, so -2, -4, and -6. So my coordinates of the function's minimum is 14, -6. For number 10, we're asked to write an interval that describes where the graph is decreasing. And so it says an interval, meaning like it doesn't have to be, all of them. It just needs to be one piece of this function that is decreasing. There's a couple different possibilities, right? We have this part of the parabola here that is decreasing. It means that when we read the graph from left to right, it's going down. I have this kind of line segment here, and then I have, this other part of the parabola. So again, those are the pieces that when I'm reading this graph from left to right, the y value is decreasing. And that's kind of what I was looking for here. So for one example, for an answer here, I'm going to go ahead and choose this first one here, this part of the parabola. And it's asking for an interval that describes where the graph is decreasing. And so we can kind of see in our answer here that we're looking for x values because that tells us where it is. Y value tells us what's actually happening. It's decreasing, you can see. And so we're going from the x value of -10 to the x value of what looks like -6. So the way we would write our answer is -10 less than or equal to x, which is less than or equal to -6. And that about wraps up our chapter 2 lesson practice, or lesson 2 lesson practice. And we should be up and running with the next one coming up here soon. So if you need more help, feel free to reach out or take a look at one of the other videos.